Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 9 from the June 2020, October 2020, C34, which is the old specification. This question here is about parametric equations, so it's now in P4. It's in the P4 specification of the new specifications now. So this question here is telling us that figure 3 shows the sketch of a curve which is called C, and it's given us the parametric equations which define that curve. So it's defined as x equals 1 minus 8 times cosine 2t and y equals 9 times sine t, and t is between 0 and pi over 2. That's kind of the range, the domain of this in terms of t. Then it says use parametric differentiation to find the value of dy dx at the point on C where x equals 5. So they want us to use parametric differentiation. Okay, they very clearly say use parametric differentiation because it is possible for us to change this into Cartesian form and then differentiate it. In fact, part B tells you to change it into Cartesian form. However, they very clearly here state use parametric differentiation. So here we don't really have that choice. We have to use parametric differentiation. Okay, so that's one thing. So to use parametric differentiation, basically we're going to use what's called the chain rule. So we want to find dy dx. They said find dy dx at the point on C where x equals 5. So we've got to find an expression for dy dx first. Now dy dx, if you're using parametric differentiation using the chain rule, is dy dt, because this is like in terms of t, the third parameter. So dy dt multiplied by dt dx. That's the same thing as dy dx. The dt's cancel out. Okay, so now we know that y is equal to 9 times sine t. That's pretty simple to differentiate. Dy dx, well, the differential of sine of something is cosine of the same thing, so it's 9 times cosine of t. That's no problem. Then the next expression we have to differentiate is we're going to find the dt dx, but let's find dx dt first because that's easier, of course. So 1 minus 8 cosine 2t. Now I want to find dt dx, but making t the subject of this is going to be a big hassle. So what we're going to do is we're going to find dx dt and then use its reciprocal. So dx dt, now to differentiate 1 becomes 0. Minus 8 cosine 2t. Now minus 8 stays as it is because it's multiplying it. So this is minus 8 cosine 2t. All right, the 1 goes because it's added to it. It's not multiplying it. So minus 8 cosine 2t. Now if you differentiate cosine 2t, you get minus sine 2t. And because there is a function inside this function, there's a 2t. It's not just t, it's 2t. You have to multiply by that 2. So you end up with getting, for dx dt, you end up getting, there's a minus and a minus is a plus. 2 times 8 is 16. So you're left with 16 times the sine of 2t. So that's using the chain rule here. Now we want to find dy dx. So dy dx is going to be dy dt, which is 9 times the cosine of t, multiplied by 1 over 16 times the sine of 2t. So we have an expression for dy dx. Dy dx, therefore, is 9 times the cosine of t over 16 times the sine of 2t. We can leave the answer like that if we want, and then we can continue to find what t is when x equals 5, because that's what we have to do. We need to substitute the value of t in here when x is 5, because at the point on C where x is 5, we've got to find what t is at that point and use the value of t to find dy dx. All right. However, I think I'm going to make it slightly easier by rewriting this using the double angle formula. We know the sine of 2 times an angle is equal to 2 times the sine of that same angle times the cosine of that same angle. So I can write this as 9 times cosine t over 16 times 2 sine t cosine t. And what happens is these cancel out. So I'm left with a more simple expression. Dy dx is equal to 9 over 32 times sine t. Okay, now it's for us to find out what what t is when x is 5. So we know that x equals 1 minus 8 times cosine 2t. So when x equals 5, you got 1 minus 8 times cosine 2t equals 5. Okay, so we're left with negative 4 equals 8 cosine 2t. So we can say cosine 2t is equal to negative a half. So 2t is equal to inverse cosine of negative a half. So you have radian mode, inverse cosine of negative a half. I think the cosine of a half is 60 degrees, which is pi over 3. So this is going to be 2 pi over 3, I think. Yep, 2 pi over 3. So that's 2 pi over 3. Therefore, t is equal to divide both sides by 2 pi over 3. So when x equals 5, t is equal to pi over 3. So therefore, we can find dy dx is equal to 9 over 32 times the sine of pi over 3. Okay, so we could even just put that in our calculator if you want to, but if you want to show the steps, no problem. That's 9 times 32. The sine of pi over 3, that's the sine of 6, that's root 3 over 2. Okay, that cancels, that gives you 16. So you're left with 9 over 16 times root 3. That's not rationalized, and the question wants it to be rationalized, of course. So we multiply both the top and bottom by root 3. So this becomes 9 root 3 over 16 times 3. The 3 cancels with the 9. So you're left with 3 times root 3 over 16. And there's your answer for dy dx when x equals 5. So this is the answer to this question. When x equals 5, t equals pi over 3. And when t equals pi over 3, dy dx is equal to 3 root 3 over 16. And there's the answer to part A. Okay, we could have, if we wanted to, instead of going through all of this, we could have, at this stage, used the calculator. So we could have just put in the calculator in radian mode, we could have put 9 over 32 times the sine of pi over 3. And we should have, whoops, it should give us the answer directly. Pi over 3. And that gives us 3 root 3 over 16. So we can do that just to make sure we haven't made a silly mistake. So that's fine. Even if you just wrote the answer down straight away from a calculator, there's no problem there. Okay, just showed you how it worked from manipulating it, but that's fine. You could write the answer straight away from the calculator. 9 over 32 sine pi over 3 and gives you 3 root 3 over 16. And there's your final answer in the form k root 3. So it's better maybe to write it as 3 over 16 times root 3. 3 over 16 times root 3, in which case the k would be 3 over 16. Okay, you don't have to write that. Just write it in this form. Okay, that's fine. Okay, so now for part B. Now part B tells us to show that all points on the curve C satisfy this equation. Now this equation is a Cartesian equation, basically. So it's asking us to convert the equation from parametric form to Cartesian form. Now, parametric form is when you have a third parameter. You have x, y, and a third variable, which is, in this case, t. Cartesian form is when you have y equals some function of x, just in terms of y and x and nothing else. Okay, just y's and x's, no t. So we've got to remove the t from these equations and express it in this form. Now, because they gave us the answer, we have to basically make sure that we, show the steps very, very carefully. Okay, so what we can do here is when you have to make something from parametric form to Cartesian form, what we can do here is, what I always like to do is to first of all make the trig ratio the subject. So I have x equals 1 minus 8 times cosine 2t and y equals 9 times sine of t. So if I make cosine 2t the subject of this, first I add 8 cosine 2t to both sides. I subtract x on both sides. Divide both sides by 8. Now cosine 2t is the subject of this. And for this one, to make sine t the subject is very simple. It's just divide both sides by 9. So I got cosine 2t, the subject of this formula, and sine 2t, the subject of that formula. Then I think to myself, how do I relate together cosine 2t and sine t? Okay, now these would relate together. If it was cosine t and sine t, I would relate them with sine squared t plus cosine squared t equals 1. and I would say this squared plus that squared equals 1, and then I've got an equation, I've got rid of the t. But I have cosine 2t and sine t. So I'm going to think about the double angle formula for cosine 2t. I know from the double angle formula that cosine of 2 times an angle is equal to, well, there's different ways we can express it. The basic way is cosine squared of the angle minus sine squared of the same angle. This is from the fact that cosine of theta plus theta is the same as cosine 2t, and from the formula book, from the addition formulae, we've got cosine a plus b gives you cosine a cosine b minus sine a sine b. In this case, we have cosine theta times cosine theta, which is cosine squared theta, minus sine theta times sine theta, which is sine squared theta. Now, we can also think, we want to express this in terms of sine, because I have a sine t here. I've got cosine 2t. I can replace cosine 2t with 1 minus x over 8. If I can express this expression in terms of sine, I have a sine there, then that will help me to combine these together. So what I'm going to do is I'm going to change the cosine squared theta here to 1 minus sine squared theta. So I have 1 minus sine squared theta minus another sine squared theta. That's 1 minus 2 sine squared theta. So that's one of the double angle formulae for cosine 2 theta. Okay, it gives you 1 minus 2 sine squared theta. You can also make it, if you want to, if we change this into 1 minus cosine squared theta, you'll end up with 2 cosine squared theta minus 1. But here, this is the one that we're going to be looking for. This is the one that will help us. So what I'm going to do now is I'm going to set up this. So cosine 2t, I'll do it in terms of t, is equal to 1 minus 2 sine squared t. Alright, so this is the same as saying cosine of 2t is equal to 1 minus 2, and this sine t is the same as sine squared t is the same as sine t squared. These two are the same. That's what this means. So now I can see that cosine t is 1 minus x over 8. So I can replace that with 1 minus x over 8. And sine t is equal to y over 9. So I can replace sine t with y over 9. And that way I have eliminated the t from the equation. So instead of cosine 2t, I can put 1 minus x over 8 equals, and instead of sine t, I can put y over 9. So I've got 2 times y over 9, and this is squared. Now for us is to rearrange it so you've got y as a subject and simplify it, and hopefully will turn out to be exactly what they've got there. So let's see what happens here. So this is 1 minus x over 8 equals 1 minus 2 times y squared over 9 squared, which is 81. Let's make this into one fraction first. So 1 minus x over 8 equals, this is 81 over 81 minus 2y squared over 81, which gives you one denominator of 81. You have 81 minus 2y squared. Let's cross multiply both sides by 81 and also multiply both sides by 8. You end up with 81 times 1 minus x equals 8 times 81 minus 2y squared. Now we can expand. So you have 81 minus 81x is equal to, that's 8 times 8, 640, what's it going to be, 648? 6, let's see what that's going to give us. 8 times 81, 648 minus 16y squared. Now we have to make y the subject of this formula. So I'm going to add 16y squared to both sides. So it becomes positive. And I've got here 648 minus 81 plus 81x. 648 minus 81 gives us 567. So you've got 16y squared equals 567 plus 81x. Now remember, we want to make y the subject. So what I can do is I can divide both sides by 16. So I have 567 plus 81x over 16. All right, now what we have to show looks like this. 9 over 4 times root x plus 7. So what we have to show is y equals 9 over 4 times the square root of x plus 7. Okay, I can see there's a 4 going to come here, but here we have 81x plus 567. So let's just rewrite this as 1 over 16 times And I'll write this as 81x plus 567. Now for this to become like that, there should be a common factor of these two. And if it has to be x here, I'm guessing 81. I'm hoping 81. 567 divided by 81 is going to give you an exact value. Yes, it does. And it gives us 7, which is what we're looking for. We're looking for that 7 there. Good. So if I take 81, this is supposed to equals, so y squared is equal to 81 over 16 times x plus 7. And therefore, we can find what y is. We can find the square root of both sides. That gives you 9 over 4 times the square root of x plus 7. And as we can see from the graph, we're only considering the positive values of y, because the graph starts from here. We're not taking the negative part of it, only the positive part of it. Okay, so therefore we don't write plus or minus. We have y equals 9 over 4 times the square root of x plus 7, which is exactly what we had to show. Okay, so there's part B done. Now for part C. We're now moving on to part C. It says the curve C has equation y equals f of x, where f is this function. So we just shown this, and this is between the limits of x between a and b, where a and b are constants. We got to find what a and b are. So the values of a and b correspond to the values of t. So we can say that when we know x equals 1 minus 8 times cosine 2t. So we can say when x is equal to 0, okay, sorry, when t is equal to 0, not x, when t is equal to 0, then we can say x is equal to 1 minus 8 times cosine of 0. Now the cosine of 0 is 1. Okay, as we can just show. So we're going to put this is going to be minus 7. I think 1 minus 8 times the cosine of 0. And that gives us negative 7. Okay, so that's negative 7. So that's one of the limits. And when t is equal to pi over 2, we've got to find what x is. X is going to be 1 minus 8 times the cosine of 2 times pi over 2, which is pi. And the cosine of pi is negative 1. So this is going to give you 1 minus 8, which is 1 plus 8, which is 9. So if I just put here pi, we'll get 9. Because cosine of pi is minus 1, so it's 1 plus 8, which is 9. Okay, so this is going to be equal to 9. So when t is 0, x is minus 7. When t is pi over 2, x is 9. So obviously the value of a must be negative 7, and the value of b must be 9. It's between those limits. Alright, so now we've got to state the range of the function f. Okay, so now we know that this is between minus 7 and 9. We just worked that out. So we got to find the range. Now the domain of a function is what values it can take on the x. So, whoops, that's a bit bigger, isn't it? Make that smaller. Okay, the domain of a function is what it can take in the x values it can take. And this function exists between x equals negative 7 up to x equals 9. Okay, so the range of a function is the values it can take on the y. Okay, so the range would be between this point and that point. The values it can take on the y-axis. So of course we can see it starts from 0, and we can work that out. When x equals negative 7, y is 9 over 4 times the square root of negative 7 plus 7, which is going to be 0. So it's 9 over 4 times 0, which is 0. But that's the lower limit. We can see that from the graph anyway. And when x equals 9, that will give us the y value, the highest point that this ever reaches, because its domain is only between minus 7 and 9. So the highest value this will ever reach is when x equals 9, as you can see from here. So we want to find the y value when x equals 9. So it's 9 over 4 times 9 plus 7, which gives you 9 over 4 times the square root of 16. And we know that the square root of 16 is 4, so it's 9 over 4 times 4. 4 cancels with the 4, giving you 9. So the highest value it reaches is 9. So therefore the range of this function is between 0 and 9. So we can say that f of x is between the values of 0 and 9, including 0 and 9. That's the range of this function. Okay, that's what they're asking us to state. Okay, we could even write it as, if you want, 0 is less than or equal to y, less than or equal to 9, but that's perfectly fine as well. Okay, that's fine. All right, so there we have the answer to part D, and that concludes this question about parametric equations. I hope that was clear. Thank you for watching. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from parametric equations can be found in this playlist, and I'll also include this in differentiation, because we did some differentiation in the beginning, didn't we? Yes, we did. Okay, so that's going to be included over here, and you can subscribe to the channel by clicking on the link over here. Thank you for watching, and see you soon.